Um, Hello, everyone. My name is Grigor, and as you maybe already know it, I'm a full stack developer. Um, well, it means different stuff. Sometimes, but in my case, it means only that I do front end and back end developer, not the DevOps stuff and I don't know whatever else. And what I want to talk about today is typical issues in Node.js, I mean server-side architecture projects, and specifically in the middle-sized Node.js projects. I mean, let's start. So, what is a Node.js? I mean, is it the same as JS? Well, the same language is JavaScript. Why do we separate them between each other? Maybe we should say that Node.js and JS is just the same. And it is the same from one point of view. But if Node.js and JS is the same, then it means that Node.js is not Node.js. I think you got my idea. Which is not true. So Node.js is Node.js. But why? Because when you do your front-end stuff and when you do your back-end stuff, you need to apply a different mindset. I mean, development of servers requires a different mindset. So let's consider you're going to build a project, and not a pet project, not a like something for training your skills, but a decent project with a team of developers, with a good budget, and with promising future. What you would do as a first step? I think you would choose a framework. There is not a lot of options when we talk about Node.js servers. Basically, they are separated to two different approaches. It's like Express or Nest.js. Express, and there are a few similar frameworks. They do not do anything. Like they do not apply nearly no additional functionality to Node.js itself. So it's useful for you if you have your own framework, like in your company or in your project, or you are a genius and you know what to do better than guys from Nest.js. And meanwhile, Nest.js is a like kind of enterprise solution. There is a lot of stuff out of the box, and it provides you a modular system, which would be really good in long term in scope of scalability and just robust. Yeah, and what is really important, it looks exactly like Angular. And when we talk about people who work with Node.js, usually those developers came from front end, and maybe from Angular. So for those who are from Angular, it's going to be really, really useful to have the same approach, the same modular approach. And when you develop this way and you think everything should be fine, I use best practices, this robust approach, but indeed it is a trap. Yeah, like this one. It's just a trap because a modular, if you're relaxed too much, a modular system might broke you. And in the way of creating circular dependencies. Yeah, circular dependency is one of the most common issue with a modular system. Let's see what Nest.js themselves talk about that. Well, of course, they describe it as a like the same way as a wiki does it or any other place. Like, yeah, class A requires class B, and class B requires class A. Common stuff. What they say, while circular dependencies should be avoided where possible, you cannot always do so. But are you sure that in your particular case, you cannot avoid them? Maybe it's not because your case is unique, maybe because you applied some wrong practices during development process. So let's take a look at this wonderful visualization I found out in the internet. Yeah, see, class A uses class B uses class A, and no additional information really. So I built myself like visualization with code. Here is really common stuff: user model, notification model. User model performs password changes feature, and it saves new password and it wants to send a notification. Everything looks well right now. But what if once the notification is sent, you need to do something with the user, like here? So basically increase notification counter. Yeah, see, it's already a SQL dependency. It's already a problem. Yeah, of course, you may say it's easily could be refactored. You need to avoid violation of single responsibility principle, and everything should be fine. But to be honest, sanctification might take a while. Yeah, usually we use something not synchronous to perform the sections, and still it might be a problem. What I suggest to do is like first approach, which could really help you and solve the issue, is observer pattern. But my idea is to use a combination of an orchestrator and event queue as an observer pattern. So not just observer pattern, but as a combination of two patterns. Let's take a look at the example. So we have the same user model and notification model. We have the same change password, send notification functions, right? Methods, whatever you want to call them. We have also additional method which increases counter. And we have also this infrastructure. It's orchestrator and event bus, event queue. Look, in this case, once you call the change password, it generates an event, password has changed event, which is going to be picked by the orchestrator, and the orchestrator knows what to do with it. It uses a notification model to send notification, while send notification method generates new event, which also been picked by the orchestrator, and then the model user model is being used to increase the counter. So we get rid of the circle dependency, but to be honest, yeah, it's absolutely overkill for this case because it's a simple case. Usually you do not have circle dependency when it's something small and simple. Usually it happens with complicated systems. But yeah, I hope you understand. I cannot describe here a complicated system. So that's why let's use what we have. But this particular case shows us that we can use it more. Now we can like be sure that change password has a single responsibility. It never do anything else. If you need to do anything else once change password is done, you do it via orchestrator, which is great in scope of testability of the system. Yeah, sure, it's not an easiest solution. Another solution I came up with, and something I wasn't able to even find over the internet, is models per business processes. Usually we build models per entities. So like if you have e-commerce, an internet e-commerce project, online market, you have entities like orders, you have entities users, clients, for example, right? Products, whatever. And if you need to, when your client buys something, it means you create an order, you maybe change your user balance, maybe not real money, but some points that you aware with these users for purchases, like bonus system. And also you need to decrease the number of items in stock, and all this stuff most likely you're going to do in the order model. But is that correct? So you maybe want to build an order processing model which would do all the things one by one. So you do not call one entity-based model from another entity-based model. You generate a new layer. In our case, it should look like this. Like this changing password model, which sounds really crazy. Never do something like this in your real projects, but yeah, but in this case, this changing password model takes whatever it needs from user model and notification model, and then just changes password and do the change password thing, the notification sending thing, and increasing the counter. Basically, we have everything, all the functionality we had before, but right now we do not have the SQL dependency anymore. Well, okay, there are also supportive approaches. I mean, not those which exactly solve your problem, but those which can help you to avoid them in future, like prevent them. Maybe they would not, but there is a possibility they would help you. First of them, of course, it's automated unit tests. Unit tests. I want to stress that, because not end-to-end tests, not integration tests, it's just unit tests. To build to make a unit test, you have to build your models, your methods by following the single responsibility principle. Like, let's return to our initial model. How would you test it with the unit test, this change password feature? You will have to mock your notification model. So it's like a red flag. If you have to mock something, well, it's all right, but sometimes you have to mock too much of everything, which is not great. And yeah, of course, when we talk about the unit tests, it's not great. So if you build a unit test and you have to mock something, think about it. Maybe you should do something in other way, like follow different approach. So let's return to the support approaches. Yeah, automated unit tests, they are always good. Like testing stuff, it's a huge thing. You feel yourself much more confident once you write tests for your code. It's really cool. Another thing is a code review. Yeah, you may say that code review do not solve architecture issues, which is true. Yeah, but from my point of view, those problems like SQL dependency or any other, they happen because of our laziness. Like, we do not want to. It's not because we do it by intents, but it's something. It's part of our nature. And the one who doesn't care if you're lazy or not is a reviewer. And reviewer would show you where you sucked and what should be done in a different way. And I think that might help, but not all the time. Yeah, of course. Another a small thing I want to talk about. It's not a huge at all, but it's a pain. And I thought, yeah, it's related to API endpoints. I thought it's something that happens only with junior level developers. And yeah, like this one. When you build this, tower and it ruins everything. But indeed, it happens with full stack developers. Yeah, that's why I strongly do not recommend you to be a full stack developer. So let's imagine this case. You have a client and you have a server. What usually you expect to be here? It's not what you see here. And client asks an API endpoint, "Hey server, make me a sandwich," which is a reasonable request. And API endpoints responds with this double cheese, triple salt, steak salami sandwich with little sticks, little slices of pickles. Why? Because it's being built by a full stack developer, usually. Well, you should separate building client side and API between two people, even if they both full stack developers. But just to avoid such cases, basically it happened because I know what exactly I need right now, and I do not care that I should care, but I might not care that what I need right now is what should be done here. Well, I would call it default behavior by default. So you do not do anything exact default when you do not ask to do this. So this client-server communication should look this way. Like, "Hey server, make me sandwich," and ShareMate takes these two pieces of bread. Yeah, that's the most simple implementation of sandwich. So I do not want, like, the problem is that if I want to use this previous API endpoint in any other place, like I build a new feature and I want to use it, what should I do? I have to put some parameters like suppress sauces, suppress double cheese, suppress everything. I need only two pieces of bread. Well, it's ridiculous. Of course it is. So yeah, what I suggest is like default behavior by default, and separating development process between two developers, at least two developers, when we talk about client-server communication. I'm quite sure that should be like really useful solution. Yeah, not a lot of things I wanted to talk about. Maybe, I hope not. Maybe there are some questions, but it's the end. Yeah, I don't think it's something that if something is not clear, of course, ask questions. But I hope everything is clear so far. Yeah. Okay, so I give my word, I pass my word to Dmytro, who is the next speaker, and yeah, he is going to tell you something about React, which should be interesting.
So, hello and welcome. Today we are going to talk about React, and the topic of my presentation is React Use Wisely. We are going to review some best practices, some interesting gotchas based on very simple examples on the one hand, but on the other hand, if you understand and manage the concept and the root cause of the issue that was going on in this example, you will be able to eventually build your skill and use this knowledge in some much more complex production-ready application. So let's go. But firstly, let me briefly introduce myself. My name is Dima. I'm a senior full-stack web developer in Innovecs. My prominent stack technologies are React plus Node.js. I have more than 5 years of commercial experience, mostly in fintech industry, and I'm fond of reactive and functional programming. So Firstly, we are going to talk about the key prop of React. This is a well-known concept, is widely used, and it seems like we're already quite familiar with why we need it and how to use it. But quite often, I was able to see some issues that developers had with this property. So let's firstly take a look on a very simple example. So here we have a list of a few items. We can add some new item, we can delete each of this item, and in each of them we have a separate checkbox. This is uncontrolled component. Let's take a look at the code. So here we have this list. We have a few items by default that we store in state. We map them over, creating this list item, this button for delete, and here we have add new icon. Okay, so we already know that if we use mapping somewhere in our render, it's important to provide the key property. But firstly, let's take a look what happens if we don't do it. So we have this familiar error about each child had to have the unique key property when we are in the process of iteration. So we already know that this is the prominent goal in order to add this property is to optimize React to help him deal with multiple items in the list in order to identify which item was actually changed. It drastically helps to optimize the render and eventually, of course, optimize the performance. But let's take a look what happens if we don't specify this property. So, for example, right now I select the first item in the list and the third item, and then I want to remove the first item. So notice please that currently we have selected item 1 and item 3. So I delete the first item, and we see that our selection is completely broken. Right now we see that only item 2 is selected. Totally not what we expected. So let's try to fix it by actually providing this key property. I will do very simple approach. I iterate over those items, so I have index. Let's provide this index. Completely reload our application. Okay, so now we see that we don't have this warning anymore because index is really unique. So seems everything to be fine. Let's try to reproduce the issue again. We still have this issue. And what is the problem here? The problem, and this is quite common problem, is with the fact that providing just index, the number like 0, 1, 2, 3, and so on, it can be not sufficient enough in quite many cases, due to the fact that React still not able to understand which item was actually changed. You mark each item with the index, but when you change the list, when you remove some item from this list, you don't provide enough information to understand which item was actually removed, and React keeps treating this list with the same order, but with wrong values that were changed there. So I also saw that some developers try to overcome this problem with doing something like this. So if index itself is not sufficient enough, okay, I will do like this. So I put some string and then leave index here. Let's take a look if it helps. Still no error, of course, but our issue, it still remains. And it's logical because we haven't really changed the root cause of the problem. By adding some static string, we still have the same pattern of setting this key. That is not correct. If we want some unique value, of course, we can try to put just timestamp. Let's see if it helps. But actually, it even made it worse because the timestamp was generated one after another and the value was the same. So we have the problem that a few items have the same key, and it will also cause us even more unexpected bugs. So now let's finally see what should be the correct solution here. The correct solution for setting the key always should be to provide some really unique value of each item. In our case, I know that the name of the item that we specify here will always be unique, and we can use it as a unique identifier for the key. So let's see if it helps to solve the issue. Yes, now it has really helped. What should we do in the situation when we receive some, for example, list from API, and each item in the list doesn't have any unique identifier? In this case, I would suggest initially, when we save this data in our state, some kind of local state of the component, I would suggest to firstly iterate over this list and provide a unique ID for each value on our front-end side. And only then try to actually iterate over each item and render it. Also, by the way, in the latest version of React, React 18, we have a useful utility like useID that we also can utilize for this purpose. Okay, and let's take a look at one more example where a key can be useful for us. So in this example, we have the component where we have a button for changing the color, and we have some external component that has a simple functionality of increasing the interval. It increases the interval each second and renders the result of this count. When we change the color in the component, in the parent component, we change the background color of the whole wrapper of our component right here. So let's take a look how it looks like. So now when we change the color, we want the count to be resetted. So we want to trigger the interval from the very beginning. When we do it right now, it's not the case. And why it's not the case? Because in the external component, we set effect without any dependencies. It means that this component has been mounted and the interval is going on. The interval will be stopped and the values will be resetted only when the component is completely unmounted from our page. Otherwise, the component doesn't have any props here, so it will not even re-render. It basically, technically it will re-render, but it will not cause any changes in the logic of the counter. Okay, what we can do here is we can specify key property put the color here. So it means that each time when the color is changed, our external component will receive a new key property. And by the way, you should not even specify this key property as a prop to this external component, because this is some property that is automatically expected under the hood for each React component. When we specify this key property and when it changes, it is a trigger for this external component to completely remount. So it means that it will recreate the state from the very beginning. It will recreate this interval, and we will receive the behavior that we expect. Let's take a look. So I have counter. Now I change the color, and we see that counter has been completely resetted. Once again, yeah, so it works like this. Of course, we can argue that in this simple example, we could avoid completely remounting the whole component in order to receive the functionality that we expect. In this case, we would be able to get the color as a prop of external component. In use effect, we can listen to the change of the color. We can stop the interval and recreate it again when the color is changed, and we can reset the inner state of the component, the count, based on the change of color. Yes, we could do all of this, but in my personal experience, this feature of using the key in order to remount the component was very useful for the cases when the external component that I use is really an external one. It comes from some different library, and I don't have any control over it. I can go to the component and change somehow the inner logic there, but I really need to get the functionality of that component from the moment when it mounts on the page. Usually it happened when I was dealing with some kind of graphic libraries, some charts, representations, and so on. So anyway, in some cases, but please notice that in some rare cases, such a functionality will be really essential for you. So to summarize the issues with key property, what I wanted you to pay attention is that you should use this property in each mapping operations in the renders of React component. This ID that you put inside the key prop, it should be really unique, and just index might be not good enough in some cases. And that you can use this property in order to trigger the complete remounting of the whole React component. Also, soon we will talk more about React hooks that are already kind of commonplace in React infrastructure, like everyone use those hooks. Basically, everyone have embraced the functional style of programming, functional components, and hooks as essential part of it. But I want to really draw your attention to, from my opinion, the most important rule regarding the using of hooks. You should not use those hooks conditionally. So if you have some condition, you have to put this condition inside the hook itself, and not try to run the hook based on some condition. And what can really help you to achieve this purpose is the plugin, the name ESLint plugin React Hooks. When you add it to your project, it will show you all the potential cases where you might be wrong with using your hooks. So now let's talk about, seems like the easiest hook that is very commonly used. This is use state. I want to draw your attention that in some cases it is really important to update the state with a callback. Let's take a look at the few examples. So here we have example 3. Okay, so here we have the following logic. When we click on the button increase with delay, we will increase the counter with each click. We want to increase it by 1, but it will happen with a little bit of delay, just 1 second. And also we have an interval that is going to multiply the current value of the count by 2. So let's take a look firstly at the code, and then we understand what is going wrong here. So we have a button. On click, we have set timeout by 1 second, where we set count just by taking the value of count plus 1. Our count and set count, those are the results of use state with the initial value of 0. And also we have interval that we put inside use effect. And there we take the value of count and multiply it by 2. And we run this interval each 10 seconds. So let's try to use this example. 1, 2, 3, 4, 5. So I clicked 5 times. But you see that actually the count was set only to 2. And then when we trigger multiplication in our interval, it even become 0. So this seems really strange. But let's try to fix this issue one after another. So firstly, what's going on with our onClick? As I mentioned, in the cases when you really rely on the previous state of your value, of the previous value, you have to use the callback approach of updating the value. It looks like this. Previous count. So we pass the function here. Previous count is the result, the value that we had before. And we can use this value and just add 1 to that one. Okay. One, two, three, four, 5. Now we see that each time the count worked correctly. But once again, when we trigger multiplication, it doesn't work. It resets the value to 0. So why it happens? Inside this use effect, we don't have any dependencies. And the value count that we rely on in this use effect, it doesn't have any chance to be updated. So right here, we are still exist in the scope where the count is always the initial count that we put inside use state. How can we fix it? Seems like the most obvious approach is, okay, if we depend on this count, we have to put this count inside the dependency list. It was updated correctly. Let's wait for the multiplication. It takes some time for the multiplication, have you noticed? And eventually it seems like work correctly. I increase it again, and still it takes more time for the multiplication to happen. Why is it? let's think what happens here. We depend on the count, and each time when the count is changed based on our clicks, when we increase it by 1 each time, we actually rerun the whole use effect hook. So we completely reset our interval. And the last time when you change the count, from that moment, there is a new set interval, and we have to wait 10 seconds again in order for it to be triggered and the value to be multiplied. So each time when we increase the value by clicking, we actually reset the whole timer. But what if we want to make it independent? In this case, once again, our callback for setting the state can be very useful. We can avoid relying on this count value in use effect, but instead we can just access the previous value directly by the callback approach. So previous count, previous count multiplied by 2. Let's reset it. It was multiplied. It was multiplied again. And now you see that we don't actually break our interval. We still have the same interval. It works independently on when we increase our value, but each time the latest value is taken from our state. So this is exactly what we wanted to achieve. So to summarize about using the state update, we have those points that you should use the callback when you really rely on the previous value. It happens just inside the regular render of the component, and it also can be additionally useful when you are inside use effect, and instead of putting the value of the state in the dependency array, you can just access the previous value when you set your state. So let's move on. Let's talk more about the dependencies array inside use effect hook. Not only use effect, it also can be applied to use memo, use callback, and other hooks, and all of this we will see in the next example. So what we really have to understand and always keep in mind is that inside the dependencies array, when React tries to estimate if the value was changed or no, it provides the comparison. And this comparison is made by the following rules. Primitive values are compared by their values. Primitive values are strings, numbers, basically booleans. Objects, arrays, and functions, they are compared by their reference. So let's take a look at the example. So firstly, I want to show what goes wrong. So we have the infinite loop, and now I have to restart it. And now I will remove some piece of code in order just to present you the idea of what we want to achieve, and then gradually we will achieve this functionality. So let's do it like this. Okay, so we have the following functionality. We have two drop-downs, the name of the artist and the type of action that we want to provide when the data has been loaded correctly for this artist. And when we select the artist, we want to load the data about his most popular works. And work like this. When we change the artist, we load the data again. And our own success action right here will be used later, because firstly, we want to understand one issue with the selection of artist itself. So let's take a look. In order to achieve this functionality, we have a custom React hook. So this is, by the way, a good example of how you can encapsulate any kind of functionality in a separate React hook and use it from any kind of component. Okay, so we have use artist info that receives some options. In our case, in options, right now, we have only artist name. So inside use artist info, we will keep the loaded data in the local state. In use effect, we are going to trigger the server request to get the information about the artist, and we will retrigger this request each time when our options are changed. And in my initial example, when you saw it was just infinite loop, I did it like this. So I put just options here, an object, because really we have to trigger this request each time when any part of our options is changed. But in this case, we received the situation when each time we load the data, we save the data, and we receive in this hook the options as a new object again. And it was retriggered again, and eventually we got to infinite loop, because we pass the options by creation of new object each time during the render. How we can fix it? The first approach is to actually memorize this value. We can do it as following. More options. So here we will have use memo. We will return the object with artist, and we should put the artist in dependency array. So it means that we will recreate the object for options only for the cases when the value for artist, and let me remind you that the value for artist is just a string, so it's simple value when it is changed. So we put it here. Let's try right now. So it works. The other approach, and from my opinion is much better approach, is to actually, you can put the artist here like this, But in the dependencies array of use effect inside our use artist info React hook, custom hook, we should put the exact value that we rely on in order to decide if we want to retrigger the request to server, the logic of use effect. So if we put specifically, if we extract specifically the property from the options and put it in dependencies, it will also solve our issue. Yeah, so you see that it works. Now let's take a look about the other dropdowns that we have. This is a success action dropdown where we can select one of two options. When we receive the data about the artist, we can change the title of the page, or we can show some alert. So let's try to also add this on success functionality to our custom hook. So I pass on success. Here I also have to include it in dependencies array, but don't call it, but just include it as a reference. And here we are going to call it when we load our data successfully. And once again, we receive infinite loop. Why does it happen? Because, as I mentioned, the objects, arrays, and functions, they are compared not by the values, but by the references. And here, inside the render, each time we create a new reference to the function that we pass further to our custom hook. So how we can solve it? We can even modify this function. So we can use callback. Use callback helps you to basically memorize the function and make it to be changed only when we actually change the value that this function relies on. In our case, our dependency is success action, because only when success action is changed, we want to recreate this on success function. So if we pass it like this, let's open our example. We see that the default success action was change title, and the title has already been changed. So we loaded the data, title is changed. So we see that we don't have any infinite loop. We see that on success action already works correctly. But right now, if I change the value of on success action, we see that we also retrigger the request and instantly apply the new value of on success action. In our case, we have selected trigger alert, so we really have this alert. And of course, when we change the artist, the latest value of on success action will be applied. So we still have alert. But what if we want to achieve the logic that we don't want to retrigger the new request when we change on success action? We want to retrigger the request only when we change the artist, but when we successfully load the data about the artist, we want to apply the latest value of on success action. So let's try to achieve it. In this case, we should not put our own success in the dependency array of use effect in our custom hook, because inevitably it will retrigger the request to server. But how can we actually save the reference to the latest value of onSuccess function? In what I've said, I've provided some kind of hint for this. We can use reference in React. Previously, references were considered something that can be used only to preserve some reference to HTML value. But later, and specifically with the introduction of the hooks, references are much more considered as a common way to preserve some data within a component, within a different updates of the component, the value that will always provide you the latest data about this value, but that doesn't trigger the render of the component itself. So let's take a look how we can use it here. We receive onSuccess from options, and we save it inside the ref. In order to update this reference each time when onSuccess function is recreated, we can use layout effect. And from my opinion, it's really a good representation at what is the difference between use layout effect and use effect. If we put the saving of this onSuccess option in use layout effect, we assure that each time when onSuccess is changed, this piece of code, the saving of this reference to our onSuccess ref, it will happen synchronously, and only when it is completed, our asynchronous use effect will run. And inside use effect, when we have to access onSuccess, we can do it like this. So we accessing this onSuccess that we save in ref, and we have to access its current value. So just to summarize, the difference between use layout effect and use effect is that you can be sure that use layout effect will run synchronously, and firstly it will preserve the latest value in the reference, and in use effect, when you actually have to access this current value of onSuccess, you will be able to always receive the latest value. You are sure that this piece of code will run after this piece of code has been executed. So let's see if I haven't missed anything, and we can try to run this functionality. So we still see that onSuccess works, at least from the beginning. I see the title has been changed. I change artist, the title is changed. Now I change to trigger alert. We see that nothing has happened because we don't want the request to be retriggered when we change this onSuccess. But now if we change the value of artist, we see that the new value of onSuccess has been applied. So this is exactly what we wanted to achieve. Also, let's briefly take a look at the state batch updates. When React has introduced the feature of React hooks. And when we so commonly use state hook, we received the possibility to split our state to multiple kind of independent parts. It helps to better focus on business logic and split the state based on the business requirement instead of having to store all the state in one object and then deal with this object each time when we provide an update. But let's take a look at one example to understand where we receive batch updates and what can we do in order to avoid having batch updates in cases when, in some really specific cases, when we want to run each update independently and trigger to instantly render the component. So this is the fifth example. So we have two inputs, the artist updates renders each time when we change the value, and the genre. And also we have reset filters possibility that should reset both inputs. Inside the code, we see that we store those states for artist and for genre in a separate states. When we click on reset filters, we will update the state for artist and for genre, but for this example, we do it asynchronously. We will update it in half a second. What should we expect? Should we expect that the value will be, that the update of each of those values will retrigger a separate re-renders, or that React somehow understand that those updates happened almost simultaneously, and it will wait, batch those updates, and provide only one re-render for optimization purposes. So let's take a look. We will try again. Reset filters. This is a single log, just displayed in a few different places for me. So we see that there was only one re-render, and the new values for both artist and genre have been applied. This is how it works in React 18. You should consider that in React prior to the version 18, so even in the 17th one, it would be not the case. If we provide a few almost simultaneous state updates without any callbacks, so not inside the timer, not inside the callback function, not inside the promise and async await functionality, it is actually promise that is under the hood also a callback. So if we just synchronously provide a few simultaneous updates, yes, it will work the same way as we see it right now in React 18. But if we do such a functionality in React in prior versions in some kind of callback function, we will have a few different renders. So firstly, it will be, for example, like artist empty and genre some value, and only then it will be artist empty and genre empty. But what should we do in the case when we still want to provide those few updates one after another? So when we want to treat each of those updates separately. React provides such a helper, and please notice that you have to import it from React DOM. This is flash sync. So let's try to use it. We have to wrap each call to state inside flash sync. Okay, now we see that we have each update separately. Firstly, artist was resetted, but we still have genre. So it was the first call to update state. And in the second update state, we have both values to be resetted. Of course, it's not a common use. There are some really specific cases when this functionality can be useful for you, but still I believe that it's important to keep in mind that you still have the possibility to do it like this. Now let's take a look about quite recent features of React that are related to suspense. Here I would have a few recommendations. I would suggest to use lazy loading to show the content only if a user requests for it. So when you have some modal, when you have the routing functionality with different pages and you're not sure that user will actually open some of those pages, you can apply lazy loading functionality there with the default value of suspense to show the loading state, and it will drastically help you to optimize your bundle and to not load all the code that most probably will not be needed to each user when they use your application. And also you have to take into account the pending and error state of your component with suspense and error boundary. So let's take a look at the example. Here, firstly, we have additional info. We can imagine that this additional info is kind of modal or kind of heavy component that we can load lazily only for the case when user provides some dedicated action in order to request for this resource. In order to load some functionality lazily, you have this lazy utility from React that expects to receive a promise with the reference to the piece of code that you want to load lazily. In this example, I specifically added some additional delay in order to show how the loading state will look like when we use suspense, and it also helps us to understand that when we use dynamic import, just a JavaScript feature, what we actually receive a promise, and we can treat it as a regular promise. We can save it to some value, then we can execute some additional logic. Like in our case, I create some additional promise in order to wait additional 2 seconds, so provide some artificial delay for this functionality, and then you can just return this promise that you receive from dynamic import, and it will be treated in the same way as I do like this. Lazy, and here in callback function, in factory function, I return this import, so I return this promise. So this is the same, but with additional delay. Here we have loader component. Those things we will discuss later. And here we have, for example, some asset. When we click on it, we want to load more information about this asset. And only when user requests for this information, when he toggles it, we introduce suspense and try to render our additional info. So only from that moment, we will try to lazily load that info, show the loader while we're waiting for it, and eventually render it on the page. So let's take a look. This is the other part that we will discuss a little bit later. But now I want to show more info lazily. So let's take a look at network. Actually, we will reload to be sure that we catch everything from network. So if I click here, we see that we load additional chunk, additional data. This is exactly the lazy loaded data that we show here. While doing it, we also was able to see the loader as a pending state. But now please notice that I hide this data again, and if I want to show it again, we don't have any additional loading of the resource of JavaScript chunk again, because we've already loaded. So it happened only once, and we have this value being stored in the resolved promise, and we are good to go. Okay, and now let's take a look about something more interesting and more complex. We will try to use our suspense logic in order to fetch the data inside the component. So let's imagine that we have some HTTP request, and we will be able to handle the pending, the success, and the error state of this request directly from our component. So let's take a look. Basically, we have a pattern that is called as resource. The logic there is following that we have the data. This is the expected result of our HTTP request. Also, we have the status of the request. By default, this status is pending. We have a potential error, and we store the promise that should actually keep the potential data about our result. So this promise we will receive after the execution of our HTTP request. When this promise is resolved, we store the status as success, and we store the data. If the promise has some error, so we receive some error while our HTTP request, we store the status error, and we store the actual error. And all of this we do when we initialize our instance of a sync resource. And we have the public method read that we're actually going to use inside our component that does the following. It checks what is the current status of the request, and in case of pending, please carefully look that it throws the promise. It doesn't return the promise, it throws this promise. And when you use the syntax like this, the suspense eventually that we will use inside our render, I will show how to do it, will catch this promise and will use it as an identification of the fallback state, floating state in our application. When we have an error, we throw this error, and it will be eventually caught by error boundary. And our default value is that we actually return the value that has been loaded. after the promise has been resolved. Then our component for error fallback, it's very simple component that just renders the error. And here we create the instance of our async resource. This is some dummy API that returns some recipes for the food. And here, when we create the instance of food resource, as a value, we have to specify the promise. And this is how our promise is created. It is created based on the fetch logic. So we fetch some HTTP resource. Then here, once again, I'm adding some artificial delay just to show the loading state more specifically. And we format the data to JSON. This is just a logic of fetch. And basically that's it. And now let's take a look at the random food component that actually uses this functionality of fetching. So if we don't do it like this, you can imagine that we would use fetch in kind of classical way. So we would use effect. There we would execute the HTTP request. We will save it in the local state of the component. But here we will try to use it very declaratively. So we have a separate food resource instance, the instance of async resource that encapsulates all of this logic for us. So here we call the read, asynchronous function read of food resource. We return, we receive a data. And you should understand that this piece of code will run only when we actually receive the data already being resolved. So when we receive the data from our HTTP request. And in this case, we can realize that inside this data we have some information that is essential for our render, like description and the name of the dish. But due to the fact that this random food, let's take a look, that it has been wrapped by error boundary and by suspense, it makes it possible to catch some additional states of this component. For example, when we call the read, and if the error has been thrown, it will happen in case that our promise has been rejected. This error will be caught inside error boundary. And in this case, we will see some fallback component. And what is interesting in that initially, when we call random food, and this HTTP request hasn't been resolved yet, the read method, it will throw a promise. Once again, it will not return it, because otherwise, okay, we would receive this data as a promise and we would try to access some values from this promise. It will not bring us anything useful, and suspense will not know anything about the fallback state. So it is important that we throw this promise, and it will be caught by this suspense that we use to wrap our random food. And it will trigger the fallback of loader. That is why actually we see the following, that right now we see the loader, and once the HTTP request is completed, we see the data from that HTTP request. Let's also try to throw some error here. So this will be an example of what will happen if our HTTP request goes wrong and eventually we throw some data. we throw error. So let's take a look. We are waiting, and then there is an error. It is caught by error boundary, and eventually we render the fallback. Please notice that the suspense functionality is available directly from the React package, but for error boundary, React doesn't have its own implementation for it right now, but I've noticed that the package React error boundary, it has become really popular for such cases. It just encapsulates the logic of component did catch and so on, and you can just easily use it in a very similar manner to how you use suspense. So you also have fallback component. You just wrap the component from where you want to cache errors, and basically that's it. Also, let's briefly mention the portals functionality of React that allows you to render some HTML outside of React root. This can be useful for the cases like modals and tooltips. So let's briefly take a look at the example. You have a portal component where you get the reference to the mount element that has to exist inside your HTML. In my case, it really exists inside index.html. We have the root where we actually render our React, and portal root that is used for this portal functionality. Then you create some wrapper for the functionality inside your portal. Then you mount it appropriately inside the root of the portal. And you have a utility create portal, and please notice that it's not from React, it's from React DOM. And here you can specify the children for this portal component and the element where you want to mount it. And then how to use it. You call the portal, and all the data, all the children that you put inside, it will be rendered in this separate mounting point. So let's take a look how it actually works. We see that this data is not restricted by the size of this parent component because it has been rendered in completely different place in our HTML. We see that our whole application has been rendered inside the root, but this tooltip has been rendered inside portal root, and this wrapper component with ID, tooltip, and portal. So it really helps you to overcome some basic restrictions of HTML and CSS that otherwise you would have to use with some CSS tricks that in some cases might be not optimal and not provide the whole scale of functionality that you want to achieve. And I've briefly touched the issue about children in React. And now let's take a look about how we can move further from that point. So the React has a dedicated children API that might be really useful for some cases in order to modify the values that you put as children inside your React component. So you can not only just render the children as they are, but you can enhance them with some additional functionality. You can conditionally render them, you can slice them, change their places, and so on. So you can basically treat them as a kind of array. So here we have the list of methods that can be applied on the children, and you see that they really help to operate with them as array. And now let's take a look at one practical example. So we have the list of instruments that we want to render to our page, and we have the possibility to add some new item. And we want to achieve the functionality that each 2 seconds we automatically change the selected instrument. So we can do it in the following way. We have a parent component that will encapsulate this logic of going over each item and actually selecting the proper instrument each 2 seconds. And we can provide instrument component, basically the list of instrument components, to this parent. Instrument component, this is just a simple box with text. But it has a property is selected. And based on this property, we decide what should be the background of our instrument. Inside the parent, where we have the logic of running this interval and deciding what is the selected item right now, we can actually utilize this React Children API that I was talking about. So we can do it as following. We can call children map, and here you have to pass the children as a property. Each React component has a default property children that you can easily access. And as a second argument, you receive each child. This is basically a React element of the child. And what is really useful is that you can do with this child many interesting things. In our case, we can completely clone this element and enhance it with additional property. So in order to do it, you have to call React API clone element, specify this React element, and as a second argument, you can provide additional props for this component. In our case, we specify isSelected property only for that prop that is currently selected. So let's take a look how it works. So those are, each instrument is a child. And we see that our interval in the parent goes on and recreates the children and enhances it with that property is selected. Okay, one of really exciting things that has been added to React 18 is the functionality of transition updates. We have two useful hooks. This is use transition and use deferred value. Basically, they try to achieve the same goal, but they should be used depending on your situation. If you have the whole control over the state updates, if this is you who is calling some state update, you can use transition. But if you want to receive the control over the state updates that happen in some external component from libraries that you don't have the direct access to, you can use default value. In our case, we will take a look at use transition. So here we have the list of 10,000 items that we want to render, and we have an input where we can use this input as a filter by name for those items. So each time when you change, you will filter these 10,000 items. My initial suggestion is basically, if you are in situations that you have to render 10,000 items on the screen, please think about it again, and there is a good possibility that you don't have to do it, that it's much better to use some approaches like pagination or some other way to restrict the amount of data that you render on the page instantly. But this example is really good in order to explain where this transition can be useful for us and what can it bring us. So let's firstly try to use this functionality without transition. So we have this input. When it changes, we just set the value, so it will trigger the filtering of the list, and eventually it will also update the value on the input. I'm trying to type right now, but it doesn't go smoothly due to the amount of data. And now I will remove all of those values, just one after another. And once again, it has stuck. And by the way, due to the share of the screen, it works even slower than I tried to do it before. Now let's try to use transition. The logic behind the transition is that you can specify the React which updates should happen as fast as possible and which updates can be deferred a little bit for further in order to optimize the performance and user experience. In our case, what is really important is to update the value of input as soon as possible, because when user types something in input and doesn't see the instant update, or at least quite quick update, it feels laggy and definitely not a good user experience. On the other hand, in terms of filtering 10,000 items, I think each user can understand that this is the process that can take some time, and it's quite expected to see some loader during this process and eventually receive the result. So right here, we will try to use transition. And by the way, this is a hook, use transition. When you call it, you receive two values. You have the value for start the transition, where as a callback, you will specify the state update that can be deferred. That basically you specify that this state update, it's not so urgent. Please deal with it when you are ready with dealing with more important things. And is pending value. This value is useful in order to show basically the pending state of your deferred update. So in our case, we are able to render some loader or somehow visually let the user know that the process of filtering of those values in the list, they are in the progress. So here we start the transition and we set filters with the value that we receive. Let's try again. It will still not be super fast, and moreover, due to the sharing of the screen, it will take some time, but we will see the difference when we clean up the input. You see that we receive the loader while the data is in progress. And when I remove the values, you see that it happened much faster. The input was not 100% responsive, but at least it was much more responsive that, without the transition. And while transition was happening, we saw that loading state. And the last example that I want to provide today, I want to share one of my favorite React patterns. This is a pattern of render props that can replace almost any usage of higher order component pattern that was very popular previously, and that was not too optimal from the usage perspective, from the perspective of typization, and that had to create those additional redundant trees of React components just in order to enhance some component with additional functionality. So let's take a look how render props can help us with it. Firstly, I will show the example of the final result. We want to introduce some functionality. Let's call it with confirm. So there we want to show some dialog each time when user wants to provide some action, and we want to ask him for the confirmation of this action. So when we click it, we receive some confirmation modal, and we can appropriately react to those changes. So if we say no, you have cancelled the action. If yes, okay, let's do it. So let's take a look how it can be implemented with render props. So here we have the component with confirm that stores the state of the opening of the dialog window. It has the utility open confirmation. When we trigger it, we set the dialog to be opened. We have handle close that will close the dialog and will trigger the on disagree callback, and handle agree that will also close the dialog and will trigger the on agree callback. And here we render all of this data about the dialog itself. that will optionally be rendered. And we render the children of this component, where we can pass all the useful information, all the useful utilities that can help the child of this component to actually use its functionality. In our case, we understand that the majority of cases, the child will be some button. And what is important for a button? To have a possibility when user clicks on this button to have a possibility to actually trigger the opening of this confirmation window. That's why in our example, for simplicity reasons, this is the only utility that we want to pass. So let's take a look how we actually can use it. We call this confirm, providing the callbacks for agree and disagree. We have this button. We use on-click handler there. And in order to trigger the opening of this confirmation, we render this button by calling the function. Basically providing a callback function here that eventually will be called in render with this utility from the parent, from this confirm. So when the user clicks, we are able to use the utility from the parent. This is quite simple example, but you can imagine that lots of functionality can be implemented in a similar manner, and it's really convenient to use. It's understandable to read, and you don't recreate those redundant trees of multiple components just to enhance them with additional functionality. Okay, and the last thing that I want to briefly mention, without any example, but just a few final thoughts from my side about the state management of React are the following. Firstly, regarding the context, I would suggest you to use context only when it comes to some global state that is rarely updated. For example, if you have some theme, visual theme, dark or light, that user selects, and it's not expected to be changed often. If you have some users permissions, for example, that you receive from a decoded token when a user authorizes to your system, you want to store those permissions and have access to them from any part of your application, but you don't expect them to be often updated. Also, regarding the context, it provides you a possibility to split the states to multiple contexts, and I would suggest you to put the context only very close to the part of the application where you actually want to use it. So, for example, if you have a few pages inside your application and the context belongs to the functionality of only one page, I would suggest not to put it on the very top of your application, somewhere where you put the router and so on, but to put it specifically close to that page where it's going to be used. Because you have to remember that each time when you update the value of the context, all of those children will trigger the render as well. Also, regarding the comparison between use state and use reducer, a quite new hook in React that also allows you to update the state, but it does it in more, let's say, organized way, where you have to provide the names of the action that you want to trigger. So basically, it's very similar to the Redux functionality and the approach with actions that you have there. So I would suggest to use Reducer for some complex state changes, because it's much more readable and much easier to debug such kind of functionality when you can clearly understand which action triggers which update. And use state, on the contrary, on all the cases where it's much readable without any additional explanations. And also, I've already mentioned a few times how you can very usefully and conveniently use ref functionality, the references inside React. So I want to draw your attention that you should think about the update of each value inside your React component, and you have to ask yourself a question: if the update of this value, will it cause the update? Will the update of this value will actually be needed for re-render, or should it be used just for some internal logic of the application? So, for example, if you're sure that when you change this value, the component has to trigger the render, you have to use state. But on the contrary, if that value should be utilized for some further usage, but should not directly trigger the update of the component zero render, you can easily utilize such a value inside the reference of the component. So basically that's it, and thank you for your attention.